Good day and welcome to Space Station Live for Tuesday, August 6th, 2013. You are inside the International Space Station Flight Control Room in the midst of a loss of signal period where the International Space Station is out of range at the moment from our tracking and data relay satellite system. The Orbit 2 team of flight controllers taking a short break before returning to consoles to oversee the work of the Expedition 36 crew on board the orbital outpost. It has been an extremely busy day so far and will continue to be a busy day for the 6 crew members on board the International Space Station. The half-dozen crew members are divided into 2 trios who arrived at the International Space Station on separate Russian Soyuz vehicles 2 months apart. On the left of your screen in this crew portrait, Alexander Mazurkin, the current station commander Pavel Vinogradov, and NASA flight engineer Chris Cassidy, who rode their Soyuz TMA-08M spacecraft from the launch pad of the Baikonur Cosmodrome in Kazakhstan to a docking to the Poisk module on the International Space Station back on March 29th. Just 2 months later, the other trio of crew members for Expedition 36 arrived: Karen Nyberg, the NASA flight engineer, Soyuz commander Fyodor Yurchikhin, and European Space Agency flight engineer Luca Parmitano, who arrived on their Soyuz TMA-09M spacecraft, docking to the Rossviet module on the Earth-facing side of the Russian segment of the International Space Station on May 29th. The day has been highlighted by a variety of activities involving Robonaut, the humanoid robot that was set up yesterday in the Destiny laboratory of the International Space Station, and which on this day was operated telerobotically by Chris Cassidy, that you see here in video that we acquired earlier in the day, as Robonaut was put through its paces, moving its head, its neck, and its arms on command from Cassidy, wearing a specially equipped vest in which he sent commands in a telerobotically fashion to the Robonaut humanoid robot to continue to gather research on the ability of robots to interact with humans on board the International Outpost. The 300-pound Robonaut consists of a head and torso with 2 arms and 2 hands. It was launched aboard the Shuttle Discovery on the STS-133 mission about 2.5 years ago, and has been acquiring critical data for researchers on the ground who are perfecting the techniques used to operate robots in orbit from ground control venues. The work of the Expedition 36 crew on board the International Space Station also highlighted today by looking ahead towards a pair of spacewalks in the weeks ahead by Russian cosmonauts Fyodor Yurchikhin and Alexander Mazurkin, as they continue to gather and prepare a series of tools that they will take outside the Pirs docking compartment with them for a pair of spacewalks on August 16th and August 22nd, clad in Russian Orlan spacesuits, to continue hooking up cables and other equipment outside for the future arrival of a Russian laboratory module that is scheduled to be launched late this year on top a Proton rocket from the Baikonur Cosmodrome. All the while, another cargo ship is headed for the International Space Station, the Japanese H-2 Transfer Vehicle, or HTV-4 as it is known, more affectionately by the name of Kanatori, the Japanese word for white stork. The HTV-4 was launched from the Tanegashima Space Center in southern Japan on Saturday, U.S. time, and has been steadily making its way toward the International Space Station, conducting a series of rendezvous burns, the latest of which is taking place to fine-tune its path to the International Space Station, where crew members Karen Nyberg and Chris Cassidy will reach out with the station's robotic arm working from a robotic workstation in the cupola of the International Space Station. They'll grapple the HTV-4, maneuver it very carefully so that its berthing mechanism is perfectly aligned with a common berthing mechanism on the Earth-facing port of the Harmony module, and then slowly but surely mating it to Harmony, where it will be bolted into place for a month's stay at the International Space Station. The HTV-4 is loaded with valuable cargo, both inside the spacecraft itself, called pressurized cargo, and unpressurized cargo that is housed on an exposed pallet in a slot on the side of the HTV-4. The cargo consists of just about 4,100 pounds of dry cargo, spare parts, and experiment supplies, some 1,257 pounds of water and 24 contingency bags, and then on the outside in that exposed pallet that will be removed robotically from the HTV-4 and handed off to the Japanese robotic arm on the Kibo module for installation on the outside of Kibo, there are 3 critical spare parts, a main bus switching unit, a utility transfer assembly, and an experiment suite for the Department of Defense called the Space Test Program 4 pallet. All of that equipment to be housed on a variety of external logistics platforms on the truss of the International Space Station. Early this morning, Luca Parmitano of the International Space Station's crew, the European Space Agency flight engineer, was in the Quest airlock continuing his work to troubleshoot a video cable associated with a camera system inside Quest that has been acting up in recent weeks. That troubleshooting effort continues. You see Parmitano working in the equipment lock section of the Quest airlock. Behind him is the crew lock section, which crew members float into clad in their U.S. spacesuits before they close the hatch, depressurize the Quest airlock, and open the outside hatch to begin spacewalks from the U.S. side of the International Space Station. Later today, Parmitano will be conducting some in-flight maintenance work as he replaces a pressure control and pump assembly for the urine processing assembly in the water recovery system that failed late last week. And that's a glimpse of all of the work that's taking place on board the International Space Station for this Tuesday, August 6th.
That's just perfect. Thanks.
And to Hal, any status on computers?
Yes, I do. I have some actions for you to do the wireless troubleshooting, and when you're ready to copy, I'll read that up.
Go for it. Ready now.
Okay, we'd like you to power cycle the wireless access points in Node 1 and Node 2. In Node 1, that's on UOP 2, and the AC inverter that's plugged in to that wireless access point, we'd like you to turn switch 1 off.
As spacecraft communicator Hal Getzelman talks to Chris Cassidy about camera setups aboard the International Space Station, the crew on board the complex involved in a variety of work, much of which takes a look at future exploration and technology advancement on board the orbital outpost, which brings us back to the commemoration today of a significant anniversary. 1 year ago today, on August 6th, 2012, a spacecraft named Curiosity landed on Aeolus Palus in Gale Crater at 12:17 a.m. Central Time after an amazing descent through the Martian atmosphere. It landed at a place that was renamed Bradbury Landing Site, less than a mile and a half from the center of the rover's touchdown target after a journey of 350 million miles that began with its launch back on November 26, 2011, atop an Atlas V rocket from Launch Complex 41 at the Cape Canaveral Air Force Station. 1 year ago today, Curiosity began to set up all of its systems to be checked out by all of the engineers at the Jet Propulsion Laboratory in Pasadena, California, and began a remarkable one-year journey of exploration that continues even today and will continue for weeks ahead. The goals of this rover, including the investigation of the Martian climate and geology, the assessment of the field site inside Gale Crater, offering unique and revolutionary environmental conditions and clues as the search for microbial life continues on the red planet, and the investigation of the role of water and whether or not water had formed over the course of centuries and eons on the Martian surface. So today we mark the anniversary of the landing of Curiosity on the surface of Mars in Gale Crater.
Okay, we copy, and they heard that. And just a backstory on this is the wireless access points are using 2 bands of frequency, and the iPads were connecting because they were using what we hope is the good band, and the other band hopefully will be recovered with this power cycle of the wireless access points.
Okay, so the 2.5 gigahertz we'll get now with the recycle.
And hopefully that's correct.
Welcome back inside the International Space Station Flight Control Room. We're joined by astronaut Cady Coleman. Cady, as we've been talking throughout the past few days, the Japanese cargo ship, the HTV-4, the Kanatori 4, is en route to the International Space Station after its launch back on Saturday from the Tanegashima Space Center in southern Japan. A series of rendezvous burns has fine-tuned its path, and it's set up for an arrival at the station on Friday. Now, Karen Nyberg and Chris Cassidy are in charge of trying to haul that cargo ship in and to make it a part of the International Space Station for a month. You had the honor and the task of actually grappling the HTV-2 back in January of 2011, about a month after you arrived on the International Space Station. Tell us a little bit about the techniques and the complexity of what they're going to be experiencing out of the cupola on Friday morning.
Well, So this idea, Rob, of having two things come close together in space and then reaching out with a robotic arm and grabbing one of them and attaching it, it's not new in that we've done it a lot of times on the space shuttle. For example, the Hubble Space Telescope. We would go rendezvous with that, reach out, grab it, spend some time repairing it. But the big difference here on a space station is that basically the space station can't move away. If things go wrong and you tip off the telescope and it starts tumbling or it just doesn't look right to you, the commander of that space shuttle can fly that space shuttle away, but the space station is way too big. So it makes it a more critical operation to get things just right. And so as this supply ship comes closer and closer, it's we always have the ability to tell it to go away if we need to, but it's going to arrive at a place, it's about, 15, 30 feet away from the station, 15 feet from the robotic arm, and that's pretty close. And so it's going to arrive there, and the robotic arm is kind of perched, ready just to move in like this. And that's Karen's job. You'll actually hear Chris talking on the radio because the person who is M2, or robotics operator number 2, who's backing Karen up, he'll probably do most of the talking, where Karen is at the controls, and she's looking at a target. And there's a camera on top of the arm, so 1 and then 2, and that camera is moving in, looking at a target where the real arm, the part of the arm that would actually grab this thing is actually about this big. I mean, it's giant. And so both of those things are moving in at the same time. She's lining up perfectly, and if when we say, okay, ready, set, go, that's when we don't want that spacecraft to decide it wants to go here or there. So we turn off the capability of it to go anywhere. And so if it was already kind of on its way sailing a little bit left, because while it was waiting, it was kind of holding itself in a little box, back and forth, up and down. If it was on its way sailing, when we say, no more jet firings for you, that means that Karen has to follow it with the robotic arm. And that's where it can be tricky. And it can be even trickier if it's on its way, with a little more force and motion. And we always have to be ready for that. So that's what they've been doing lately, is just getting ready to, practicing following something that is racing away from you.
And does the mass of HTV-4, 16 tons of mass, does that make it even more complicated?
It does make it more complicated because we basically don't want to hurt the robotic arm. We're going to have supply ships arriving again and again at the International Space Station. And if it was racing too fast and you caught it in such a way that you didn't just kind of go with it, then that could strain the arm, put forces on the arm. So it really has to be a very precise, very much lined up operation. And, I was nervous doing it. I'll tell you, I was certainly nervous doing it. And at the same time, that's where your training comes back into play, where you've practiced this over and over again. And knowing that you've done your best to be ready, that's when you can put all that stuff out the window and just kind of focus on doing what you've done many times before. It's just, I'd say what's significant is that in the training, in the sort of cartoon virtual reality world that we train in, nothing looks that big. I mean, this thing is huge, and it's right next to the window of the space station, and it's pretty cool looking down at the Earth as it gets bigger, throughout the day on their Friday, our Thursday night. That thing is going to look like a tiny little speck on the horizon, and then it's just going to get bigger and bigger and bigger, and by the time it arrives and you're going to catch it, it is huge.
So they're going to be operating out of the cupola, which of course is the station's wonderful window on the world. But in reality, it's pretty cramped quarters. So you have Karen and Chris side by side. Luca's right there monitoring the spacecraft systems, making sure that it's doing what it's supposed to do. How How much of a kludge is that for the crew?
It is challenging because it is physically close. There's really not any more room than you and I sitting here. And yet they've actually practiced just that. I mean, just yesterday morning, they practice using the robotic arm and figuring out who's going to be where, and when somebody needs to reach that button, do they knock Karen out of the way? You know, they'll have figured out their own way to sort of use that space and their own communication together too, of saying, you know, as the arm is approaching, we need to make sure that the spacecraft is in a certain state. And so, you know, Chris Cassidy will be looking at that and telling Karen, you know, the spacecraft is free drift, you are go to proceed. So there's a lot of precise communication back and forth. And, you know, we're NASA, we practice that stuff. And we practice what if this happens, what if this happens. There'll be one more significant practice session on basically their Thursday morning to just reinforce, you know, we have all these what if situations. What if suddenly the spacecraft shows that it's got some systems that are not ready, and it would be better to send it away and wait until we can understand the state of the spacecraft. There's two things that Chris can do. He can push a button that says retreat, which means it goes back to the last place it waited, which is about 100 feet away. Or he can push a button that says abort, which actually sends it, you know, to a very far away waiting place. So, excuse me, they've got some options. We really talked through and practiced those options. And also then on top of that, you want to capture these moments, both for an engineering reason. What if something goes wrong? You want to understand. You want the ground to understand. What do we need to do different on the next supply ship? And also you just want to capture the fact that this is a significant thing that real people are doing.
And then once it's captured, the crew takes a quick break, catch its breath, and then they go through this finely choreographed procedure to maneuver it into place so it can slowly but surely be mated to the Earth-facing port of the Harmony module. So how complex is that? How precise a maneuver is that? Because in part it's also ground-assisted here by the robotics officer in mission control.
That's correct. And, you know, we're always torn in terms of who gets to do the work on the space station. Ideally, as a crew member, as an astronaut, we want to do all the robotic arm stuff because we love to fly things. We like to do things. But it's actually more efficient for the controllers down here to make some of those moves where they take it from out here where you captured it to then a position that is all lined up but about 6 feet away from being mated to the station. And so it's more efficient for the ground to go ahead and make those moves, so they probably will make those moves. But whether the crew makes them or whether the ground makes them is no matter what, there's math involved. And those things have been figured out ahead of time. And it's a precise set of coordinates. But then when you really are going to put metal to metal, and, you know, the HTV has like these kind of, you know, little cutouts like this, and then the space station has ones like this, and so those things are going to touch, and they really have to exactly kind of mesh together. That's where the ground can do that. I mean, we're getting so the ground could do that, where they bring it in and we see little indications, doing well. We can actually feel with the robotic arm, it's got sensors that say, hey, I'm being tugged this way, I'm being tugged this way. And so as we do that, we actually see how much strain is on the arm, so we can make sure that even if we think our math is correct, what if something's wrong? You know, are the mechanical parts really meshing together without putting strain on the space station? Because we need that port again, and we need to be able to undock safely and send our supply ship, now trash ship, away. And we need to make sure our robotic arm isn't getting strain either.
And so once in place, ready to latch, indications are seen by the crew, and then it's a matter of bolting it in place in a two-stage fashion, and then it's part of the space station for the next month, so its valuable cargo can be unloaded. Cady Coleman, 180 days in space on 3 flights, 159 days in space as part of Expedition 2627, and who captured HTV-2 about 2.5 years ago. Thanks for joining us today with the insight. And just a note, our programming on Friday morning in 2 parts will be on the air at 5 a.m. Central Time, 6 a.m. Eastern Time for Rendezvous and Grapple of the HTV-4, with the actual capture expected just before 6:30 a.m. Central Time on Friday morning. We'll take a break, and then we'll return for live coverage of its installation beginning at 8 a.m. Central Time, 9 Eastern Time, all of that on Friday morning. Thanks very much, Cady.
You're welcome. It's going to be really exciting.
This is Mission Control Houston. Once again, the Expedition 36 crew involved in a variety of research activity today, as well as the technological demonstrations with Robonaut that we'll talk about a bit more a moment from now. One of the activities Karen Nyberg has been involved in throughout the morning was the setup of the Marangoni experiment in the Kibo module, the Japanese experiment module that is mated on the U.S. segment of the International Space Station. This Marangoni investigation, another of several such research investigations being carried out by the Japan Aerospace Exploration Agency to investigate Marangoni convection. That's a process driven by the presence of a surface tension gradient as produced by differences in temperature occurring at an interface between liquid and gas. This is a periodic research that goes on in the Kibo module involving a variety of equipment that you're seeing Nyberg set up that is commanded on and off by the flight control team at the Japan Aerospace Exploration Agency's Control Center in Tsukuba, Japan. That experiment has been ongoing now for a number of years, yielding some valuable research results for the investigators involved for JAXA, the Japan Aerospace Exploration Agency. The Marangoni experiment, again, set up earlier today by Karen Nyberg in the Kibo module of the International Space Station. Once again, looking at flight engineer Karen Nyberg of NASA as she worked in the Kibo module of the International Space Station, setting up the Marangoni investigation. That is a periodic research investigation operated by investigators affiliated with the Japan Aerospace Exploration Agency that studies gas and liquid differences and acquires data that may one day be very important in formulating new materials in the microgravity environment. Back here in the flight control room, the Orbit 2 team of flight controllers watching over the activities of the Expedition 36 crew on the International Space Station. Flight Director Richard Jones is on console at this hour. He is supervising this shift, which basically handles all of the activities associated with the second half of the crew's workday. Jones joined today by spacecraft communicator Hal Getzelman, who is the communications link between the flight controllers here in the International Space Station Flight Control Room and the crew members on board the International Laboratory.
Not have any objections. If you object, you do have objections, then we need to cancel the FSS. Then we need off the timeline for today.
As mentioned before, the Japanese HTV or H2 transfer vehicle, Japan's big cargo ship, continues its true course towards the International Space Station and an arrival on Friday morning for its grapple and berthing on the Earth-facing port of the Harmony module. Chris Cassidy and Karen Nyberg will be in charge of robotics, with Nyberg as the lead robotics operator out of the cupola, maneuvering the station's Canadarm2, the robotic arm, into place to latch onto a grapple fixture on the HTV-4 and then maneuver it around for its ultimate berthing on the common berthing mechanism on the Earth-facing port of Harmony, where it will then be bolted in place for a month-long stay and the unloading of some 3.6 tons of cargo, a lot of which is inside the HTV-4 itself in racks, some of which is located on a pallet, which is inside a slot on the side of the HTV-4, known as unpressurized cargo, that is essentially comprised of 3 critical spare parts that will be housed on the truss of the International Space Station. And Chris Cassidy, as we mentioned earlier, continued to work with the humanoid robot, the Robonaut, in the Destiny laboratory of the International Space Station, wearing an operator's vest. Cassidy sent commands to maneuver Robonaut's head and its arms and its fingers. All of that work overseen by payload controllers at the Marshall Space Flight Center in Huntsville, Alabama, as Cassidy sent verbal commands through this equipment that he donned to maneuver Robonaut and enable it to respond to those commands as more data collection continued to make sure that investigators have a robust database of all of the work that has been conducted with Robonaut and a better understanding of how humans may interact with humanoid robots in the microgravity environment of space. As you can see, Robonaut responding to those verbal commands from Chris Cassidy, all set up in the Destiny laboratory. This work has been ongoing throughout the course of the day as Cassidy has been interacting with the humanoid robot that has been operating flawlessly. All of its responses to those verbal commands resulting in this movement that you see in this revolutionary interaction between human and robot in the microgravity environment of space. Cassidy not only offering verbal commands, but also moving his arms and the software associated with the telerobotically operated vest that he's wearing, enabling Robonaut to move in a likewise fashion. Here in the International Space Station Flight Control Room, work continues by the Orbit 2 team of flight controllers, and we'll bring to an end an abbreviated version of Space Station Live today with a couple of programming notes. Coming up at 9:45 a.m. Central Time, 10:45 a.m. Eastern Time, the Jet Propulsion Laboratory will present a special program recapping all of the accomplishments of the Curiosity Mars rover that landed in Gale Crater on the surface of Mars exactly 1 year ago on August 6th, 2012. That Jet Propulsion Laboratory program coming up on NASA television. And then at 11 a.m. Central Time, noon Eastern Time, NASA headquarters will take the cue from the Jet Propulsion Laboratory and present a special program talking about the path to future robotic and human exploration, as it also reprises Curiosity's first year on the Red Planet. Within that, there will be an in-flight discussion between Karen Nyberg and Chris Cassidy on the International Space Station, along with officials gathered at NASA headquarters in Washington, including NASA Administrator Charlie Bolden. That interactive discussion to take place at noon Central Time, 1 p.m. Eastern Time, within the body of its Curiosity Anniversary program. So you'll want to stay tuned for all of that programming on NASA television. And until then, we'll call it a wrap for the day on Space Station Live. We'll see you back again on Wednesday at our normal time of 10 a.m. Central Time, 11 a.m. Eastern Time. At a mission elapsed time of 131 days into Expedition 36, this is Mission Control Houston.